Hi, my name is dr. Ahmath. Today we're going to talk about the functions. So the calculus is the study of the continuous change of the functions. So we study most of the time the functions. We're talking about the functions all of the time. And if you just go outside and ask people what is the function, so the first thing which comes to your mind or comes to the mind of the people is simply the y is equal to the x. Or sometimes y is equal to the x in a square. So most of the time we understand under the functions like some mathematical symbols without understanding or without giving any values or any meanings for this x and y. So today we are going to look through the different forms of the functions applied to explain different things around us. So we can use the functions in order to explain the different physical phenomena. For example, we can use the functions in order to understand how much we have to pay for the parking. So let's assume that you went outside and you have to pay for the parking like 2,000 sims per hour. And if you would like to stay just 1 hour, you're going to pay only 2,000. If you stay 2 hours, you're going to pay like 4,000. And if you stay like 3 hours, you're going to pay 6,000. And if you would like to stay 4 hours, you're going to pay 8,000 sims. And if you just connect all of these beans, you're going to get just a line. So we call this line as the linear function. And it is going to be in the form as like if you just give some number of the hours, it is simply going to multiply this to the 2,000s and it's going to give you the sum. Okay, so in general, the linear functions are going to be in the form of y is equal to the kx plus b, where here this k is going to be called as the slope of the line, and the b is going to be called as the y-intercept of the line. So let's try to understand in more details what does it mean exactly this k and b and how the values, changing the values of the k and b are going to change the shape of the function. So essentially the k is going to just change the rotations of the line. So by just changing the values of the k, we're going to rotate the lines differently. So my echelon linear function is the function which basically splits the first quarter exactly to the 2, which is basically passing through exactly from the middle of the x line and the y line. So for this line, I've got the slope to be equal to the 1. So the form of this function is equal simply y is equal to the x. Okay, so you see, so as you are going to rotate the function towards the y-axis, the slope is going to be increased. For example, the slope of this line probably is equal to the 2. Sorry, so it is like, or I can write as 2x, okay? The slope is equal to the 2. And if you're going to just rotate this towards the x-axis, the slope is going to decrease. For example, the slope of this line is probably equal to the 1 over 2. Okay, so this is how it works. So every horizontal line is going to have the slope to be equal to the 0, and every vertical line simply doesn't have the slope because it goes until the infinity. So when we are defining the two lines which are parallel or perpendicular, we're always going to use the values of the slope. So I will give you a small hints about how you can identify the parallel lines or the perpendicular lines. For example, if you've got the two lines which are parallel, then the two slopes should be the same. And if you've got like two lines which are perpendicular, and their slope, the multiplication of their slope should be equal to the -1. So we're going to talk about this values, these things a little bit in more details later on in our next lectures as well. So now let's try to understand what does it mean the b. So what does the change the b is essentially the height of this function. Where exactly this function is intersecting with the y-axis, if it is intersecting. I mean, if it is not a vertical line, it is always going to intersect with the y-axis at some point, right? So for example, this is going to be y-axis, and here this is intersecting at the point 3. So that is why this line is going to have kx plus some slope. We don't know this, right? So plus the 3. Okay, so this plus the 3 or this plus the b is going to tell you where exactly this line is passing through the y-axis. So let's do a small example in order to construct the line, or in order to sketch the line. So let's say we're given the y is equal to the x plus 2 line, and I would like to sketch this. So the easiest way to sketch the line would be to just like put the 2 points and connect them. I mean, even though now we understand how this line looks like, right? So I know that the k, the slope of this line, is equal to the 1. And I also know that the b, the y-intercept, is equal to the 2. It means that the line is passing through the middle of the x and y axis. So x and y axis. And at the same time, it is passing through the point 2, right? So it is going to passing through this point. Okay, so this is how I can imagine the line. But if I would like to draw the line exactly, I need to generate the 2 points from this line, on this line. So these 2 points are going to be like this. So I'm just going to give any value for the x, for example, x to be equal to the 0, and substitute this to here. And if you substitute x to be equal to there, you're going to get y is equal to the 2. So my first point is ready here. So 0 and 2 is going to be my first point. In order to figure out the second point along this line, I can just give any value now for the x again. So they assign the x to be equal to the 1 and substitute this to here, and you can get y is equal to the 3. So the second point is going to be here with the coordinates 1 and 3. And you can just connect these 2 points in order to figure out the graph of the line. Right, so it confirms all of our all our predictions. Like the line has the slope to be equal to the 1, it is passing through the point 2, and so on. But again, if you would like to draw the line, you need to know 2 points. So at the same time, sometimes we might be interested to solve an inverse problem. So when you are given 2 points and you need to figure out the equation of the line. So any equation of the line is going to be found by just finding the 2 parameters, k and b. So that is why the process of finding the equation of the line is always done in the 2 steps. In the step number 1, we are going to find the slope of the line. So the k is going to be equal to, so the y2 minus y1 divided to the x2 minus x1. Okay, so where the y2, y1 and x2 and x1 are going to be the coordinates of the points. Okay, so here it is going to be x1 and y1 are going to be the coordinates of the first point. So the x2 and y2 are going to be the coordinates of the second point. We are going to just put the values to here and calculate the slope of this line. So the y2 is 3, y1 is 1, so this is divided as x2 is 4, x0 is 0. So it is going to be 1 over 2. The slope of this line is 1 over 2. Right? So I can see that the slope is less than 1 from the 2 points as well. So in the second step, so we know that the equation of the line now looks like a 1 over 2x plus the b, and we have to find this b, right? Fortunately, we know the 2 points passing through this line. So it means that if you just take this point and substitute this to this equation, or take the second point and substitute this to this equation, it should work, right? So I'm just going to substitute this b point into here. So this is going to be 3 is equal to the 1 over 2 times the 4. So instead of y, I substitute the 3, and instead of x, I substitute the 4. Plus the b. So from here, it is clear that the b is equal to the 1, right? Okay, so the equation of the line, which is passing through these 2 points, is going to be equal to 1 over 2x plus the 1, right? So I'm just going to connect these 2 points. So sorry for my bad graphics. But it was clear from the beginning that the y-intercept is equal to the 1, right? Because it is intersecting the y-axis at this point 1. So this is all about the linear function. So now we can figure out what does the function, right? So that you see, so if you are just assigning some values, so x, it is always going to give you some y values. So this is the general rule for any function. So the function in general is some sort of a machine, so which takes some input, makes some transformations, and then it's going to give you an output. So depending on what type of the transformations this function is doing, we are going to call these functions differently. So if, for example, if it is taking the x, the input, and if it is just multiplying this input as a constant and adding this as a b, we call this machine as a linear function. But if it is taking the x as an input, square this, multiplies this as a constant, plus multiplies the input to another constant and adds another third constant here, we call this function as the quadratic function. So there are many types of the functions, like linear functions, quadratic functions, exponential functions, trigonometric or logarithmic functions. So today we're going to talk about two more functions, like the quadratic functions, and also we're going to talk about the exponential functions. So let's talk about the quadratic functions. In order to do this, I'm just going to give you a small problem. So let's say the farmer has 240 meters of fence and he would like to build a farm near the river. So he would like to make the farm in a rectangular shape where he has to put the fence only into the three sides, not to the four, because there is one, the last part here, this part is going to be simply opened. Okay? So what he has to do is he has to use 240 meters of fence and the area should be maximized. Okay? So it means that if he chooses the height of this area to be equal to the 40 meters, then the width should be equal to the 160, right? So the width is always can be found from the height by just subtracting 2 times the height from the 240, always, because the sum of the three sides, the widths plus the two heights, should be equal to the 240. So that is why if you are giving some value for the height, so the width is going to be pre-described already using the height. So it is going to be 160 meters. And in this case, the area is going to be 160 times the 40, which is 6,400 meters square. But this is not only a way how we can create a farm. So we can create a farm differently. For example, if you choose the height to be equal to the 100, then if you substitute the 100 to here into this formula, we can get the width to be equal to the 40 meters only. And in this case, the area is going to be only 4,000 meters in the square. So the question is how we need to choose the height and the width of this farm so that the total amount of the fence which you use is going to be equal to the 240 meters, but the area is going to be maximized. So it appears we can do this by just understanding that this function of the area is the quadratic function. So any area is always going to be, any area of this farm is always going to be the multiplication of the width to the height, right? So I know that width can be always found from the height by just subtracting 2 times the height from the 240. And I'm just going to substitute this to here. And if I just open the brackets, I'm just going to get the quadratic function, right? So you see, so this is like a h in the square. So you see here, the h in the square multiplied to some constant and h multiplied to some constant, right? So this is typical quadratic function. And if you remember from the quadratic functions, so here the coefficient before the h square defines the concavity of the quadratic function. So since this is negative, it means that this is concave downward, right? So, and if you look to the graph of this function, the graph of the function is going to look like this, okay? So what we can do is we can just choose some point and just go until the vertex of this parabola, the graph of the quadratic function, and we can figure out that the vertex is going to be located at the point h is equal to the 60. And if you substitute the 60 to here and to here, you're going to get 7,200. Okay? So it means that the area can be explained using the quadratic function. And it can be maximized by just finding the vertex of this quadratic function. And now we know what is the maximum value. Okay? So if the farmer chooses the height to be equal to the 60, and consequently the width to be equal to the 120 meters, then the sum of the three sides is going to be equal to the 240 meters, and the area is going to be maximized. So this is one of the cool examples of using the quadratic functions in a real life, where we can maximize the things up. So another important functions, another important type of the functions is called like exponential functions. So most of the time they can help us to understand the growth or the decay of a lot of biological and chemical stuffs around us. For example, we can understand how the cells are splitting or the number of the cells over the time using the exponential function. So let's say you've got a cell, just one cell, at an instant, so at the initial time, so that when the time is equal to the 0, you just got one cell. Now let's assume that the cells are going to split to the 2 every second. So it means that after 1 second, you're going to get 2 cells. After 1 more second, you're going to get 4 cells. After 1 more second, you're going to get 8 cells, and so on. And now, if you are going to just put the points onto the graph, like onto the XY axis, by just putting the amount of the time, like at the time versus the number of the cells, you're going to get the exponential function. So essentially, the number of the cells is going to be equal to the 2 in the power of the time, right? So in this case, the time is going to be our input, and the number of the cells is going to be our output. For example, if I would like to know how many cells I would like to have, like after 4 seconds, I just need to substitute time to be equal to the 4. It's going to be 2 in the power of 4. It is going to be 16. So if I would like to know how many cells I'm going to have after 5 seconds, it's going to be 2 in the power of 5 is equal to the 32, and so on. Okay, so the exponential functions can help us in order to model the growth of the cells. We can know exactly how many cells we're going to have after a certain period of time, or we can do the inverse operation. We can figure out how much time it is required to increase the cells to, for example, 1024, right? So essentially 10 seconds. Okay, so this is not only the application of the exponential function. I just would like to show you a little bit more complicated model of the exponential functions. So we usually use the exponential functions in order to make the radioactive dating. So you probably have heard about that the dinosaurs used to live like 100 million years ago, or when the anthropologists found a bone, they say that, hey, this bone is dated, is aged to 10,000 years ago, or even the age of the Earth is roughly 4.5 billion years ago. So how did scientists calculate those numbers? So do they like just guess the numbers, or do they use some fancy tools in order to calculate those things? It appears everything is much more simple. So they use simply the exponential functions in order to calculate, in order to figure out the date, the age of the things. So that everything works, everything starts from the high level of the atmosphere. So the atmosphere contains lots of chemical elements, and one of them is called like a nitrogen. So the nitrogen 14, so it means that it has 14 elements, like 7 protons and 7 neutrons. So when the new free neutrons are going to hit the nitrogen, it is possible that it is going to extract some of the protons and is going to be substituted with the neutron. It becomes carbon-14. So we know that the plants on the Earth consumes the carbon, and we consume the and the animals consume the plants, and we consume the animals, right? So you see, so it appears there are 2 types of the carbon. So there is one, the ordinary one, the carbon-12, which is all of the plants are consuming. And also there is a radioactive one, carbon-14, which is basically made from the nitrogen-14. Okay, so it means that this carbon-14 is radioactive. It means that it is not stable. So over the time, it is going to be vanished. Okay, but as we are alive, the concentration of the carbon-12 versus the carbon-14 is always going to be the same for all of us on the Earth. So for all of the animals, for all of the humans, and so on. But as we stop consuming the carbon-14, so as some animals are died, so they stop consuming the carbon-14, the concentration of the carbon-14 is going to decay. And it appears that it's going to decay using this law, the exponential law. So we can denote this using the equation, like the I, which is going to be the concentration of the carbon, is going to be equal to the initial concentration times to the e in the power of minus kt. Okay, so over the time, so this t here is going to be the time, and here I've just got the I. Okay, so if you just sketch this curve, you're going to get simply this graph. So over the time, the concentration is going to decay using this law. And for the carbon-14, we've got like the half-life time. So the half-life time of the carbon-14 is equal to the 5,730 years. So what does it mean? It means that as we're alive, we've got like 100% of the carbon-14 concentration, okay? So as we stop consuming this after some period of time, so the concentration of the carbon-14 is going to decay. And after 5,730 years, so the concentration decays to the 50%. Okay? So I would like to solve the problem. So let's say I've just got some piece of the wood from like a variation time. Okay, so we just found this with the archaeologist, and I would like to figure out what is the age of this wood. So I just like measure the concentration of this wood, and I figure out the concentration of this wood is 75% of the concentration of the carbon-14 on me, okay, while I'm alive. So in order to solve the time, so in order to figure out the age of this wood, I'm going to solve the problem like this. So the I is equal to the I0 e in the power of minus kt. I know that I divided to the I0 is equal to the 0.5. It means that so the I is always going to be the current concentration, okay? The I0 is the initial concentration. So the current over the initial is equal to the 1 over 2, means that the current concentration is twice lower than the initial concentration, right? 0.5. It is possible to get this value when the time is equal to the 5,730 years ago. Okay, so now I just would like to figure out what is the value of this coefficient k. Okay, so by just knowing the half-life time, we can always figure out the value of the coefficient k. So I'm just going to take the ln from both of the sides in order to figure out what is the k. So the ln of 0.5 is going to be equal to the minus k times the 5,730, and from here we can find a k by just using the calculator. You can just figure out what is the value of the ln of 0.5 and divide this as a negative 5,730. You're going to get 1.2 10 in the power of minus 4. Okay, so now I know exactly the equation of the decay of the carbon-14. It is going to be I0 e in the power of minus 1.2 10 in the power of minus 4 times to the t. Okay, so now we know the concentration, right? So the concentration, the current concentration over the initial concentration is equal to the 0.75, right? So this is what is given. So it is the 75% of the initial concentration. Okay, so and this should be equal to the e in the power of minus k, so we know what is the k already, times the t. So we need to find the t from here. So I'm just going to find a t here. So just by taking the ln from both of the sides, it's going to be ln of 0.75 times is equal to minus kt. And from here, if you find a t is going to be ln of 0.75 divided to the minus 1.2 10 in the power of minus 4, right? Because this is the value of the k. And this is going to be roughly 2,377 years. Okay? So if you found a piece of wood, and if you measure the concentration of the carbon-14, and if it is like 75% versus your concentration, it means that this wood is aged roughly 2,400 years old. So this is how we can figure out the ages of many different ancient things. So, but of course, like it doesn't work for for the things with a long period of time. So it works, for example, if you found a bone, and if the concentration of this bone is 50% as the concentration of the carbon from you, it means that this bone is aged to the 5,730 years ago. So for these stones and for the other things, like the earth, we are going to use the other type of the radioactive elements. Like we're not going to use the carbon already. We're going to use, for example, the uranium. And the half-life time of the uranium is 4.5 billion years old. And this is how the people figure out the age of the earth. So this was just an introduction to the fascinating applications of the functions. So the functions are not always the symbolic values, some mathematical symbols. The functions has lots of values, and by just learning the functions, we can understand ourselves and all of these physical phenomena which are going around us much more better. So thank you very much for your attention. I hope that this was helpful for you.